great pleasure to welcome you today, and thank you for taking the time. You're all sitting in front of your screens and looking forward to learning more about the future of textiles right now. But I'd like you to start by kind of taking a moment and just looking down at yourself and feeling what you're wearing. What are you wearing today? What materials are you sitting on? What materials are you looking at in your space? Do you have pet tapestries like I do? What are you surrounded by? And just imagine how different our interaction would be today if the textiles on your body and in your body sometimes and in your surroundings adapted to your current state and needs, or if they communicated with you and your computer or others in this virtual space that we're in right now. And just imagine what that might mean for our environment and our relationship with nature. So I'm so happy to be exploring these questions and many more all around the future of textiles and the fabric of time today with you all at this laser talk. My name is Alexandra Muller-Krapon, and I am the head of the arts programming here at Swiss Next Boston, the Swiss Science and Technology Consulate that focuses on creating networks between Switzerland and the US in the areas of education, research, innovation, and the arts. We've partnered with SciArt Initiative to bring laser to Boston because these events embody the interdisciplinary dialogue and connection that we so value at Swiss Next. We have three wonderful speakers for you today who will be sharing their work with you. Nina Bachmann, Head of Technology and Environment at the Swiss Textiles Association and Interim Executive Director of EcoSwiss. Julie Fuentes-Medel, Program Manager of Fiber Technologies at MIT and Advisor at the MIT Innovation Initiative and the Closed Loop Partners. And Jenny Sabin, Architect and Professor of Architecture at Cornell University. And we very much look forward to all three of those talks. And I just am going to put in a little plug here since we all really miss the networking part of our in-person laser talks that unfortunately right now are not possible. We will have the opportunity for more personal exchanges today and kind of space to discuss them in person in this month's edition of Crosslinks, which is a networking platform that we host at Swissnext on the platform called Remo. This will give us the chance to unwind, chat, and weave some new connections with our other laser attendees and members of the Swiss Next network. You'll be able to sign up for the networking on Remo right after this event in the link that my colleague Lemon is sharing with you right now. It's very easy to navigate. It's all browser-based, so there's no need to download anything. Just sign up during this event, or at the end, we'll repost the link as well. Now let's take it away. Julia from SciArt Initiative will give you a little intro to SciArt and laser, and then she has the pleasure of introducing our speakers.
Thank you so much, Alex, and thank you to everyone who has joined us today from, I imagine, the United States, but also around the world. So I look forward to hearing from you all and getting to know some of you in Crosslinks after this event. So my name is Julia Buntain-Hoel. I am the founding director of SciArt Initiative, which is a US-based nonprofit dedicated to bridging the gulf between the arts and sciences. We have a number of programs that work towards this end, and one of the programs that we co-run with Swiss Next Boston is LASER. LASER is a program of Leonardo Art, of the Leonardo Group. It stands for Leonardo Art Science Evening Rendezvous, although of course many lasers don't take place during the evening. And LASER was initiated in California by Leonardo, which is the International Society for the Arts, Sciences, and Technology. LASER talks have grown to become an international program of evening and otherwise gatherings that bring artists, scientists, and practitioners of all fields together for informal presentations and conversations with engaged audiences. So we are thrilled to have our three amazing speakers here with you today to talk about their points of view on the fabric of time. LASER is really about bringing together different professionals from different disciplines to talk about a common theme, but through their own lenses and showing their work that's made with their own tools. So our first speaker today will be Nina Bachmann. Nina Bachmann is Head of Technology and Sustainability at the Swiss Textiles Association, a member-based organization committed to ensuring that the Swiss textiles industry stays internationally competitive, representing the interests of over 200 companies in the industry. Nina creates links between the industry and academic research and supports members in environmental and energy-related issues. She also serves as the interim executive director of EcoSwiss, the organization of Swiss businesses for environmental protection, occupational safety, and health protection. She holds a Master's of Science in Environmental Sciences from ETH Zurich and a Master in Public and Nonprofit Management from Lucerne University of Applied Sciences and Arts. Nina, I will let you take it away.
Thank you, Julia, for this nice introduction. I just start my presentation about textile circular economy in Switzerland or sustainability in Switzerland. Maybe just to begin with a short introduction about Swiss textiles. You already said that, Julia, but who are we? What are we doing? We have 200 SMEs mostly. Companies, textile companies that are our members. We are member financed. So we do services for our members, and we have different activities in different topics. One of them is sustainability and one of them is research, and I'm head of both these really interesting topics which are coming closer and closer together at the moment. All of our SMEs are active in international markets and they have production in Switzerland, but this is changing a lot, especially at the moment. Production is going international for most of our members. Our members do not make clothing, they do high fashion. So we see here Rihanna and George Clooney and his wife wearing brodery from St. Gallen, which is a place here near to Zurich. It was produced in Switzerland, and we are not only active in the fashion sector, we are also, a lot of our members are doing high tech. For example, here you see for the Formula One.
Nina, this is Alexandra. Sorry, we just can't see your slides right now. Could you make sure to share your screen? Thanks so much.
Yes, sorry, I try again, maybe. Can you see it now or not yet?
Yes, now we can see it.
Okay, perfect. Sorry. Yes, our members just do also, this was the picture I showed before, the high fashion picture, and then we have the high tech picture. What our members do here, the production of Formula One or mobility textiles, which you see on the left and on the right side. So sustainability at Swiss Textiles is really, I think in the last 3 to 4 years, it became the most important topic here in Switzerland. We established different services for our members. For the textile companies, we have consulting services. For example, we have consulting for sustainability standards, which are quite numerous in textile, as you might know. Then we have projects where we look at the CO2 emissions in the supply chain of the Swiss textile companies, and we do consulting for due diligence, especially for the OECD due diligence guidelines, which might become regulation also in Switzerland within the next 3 weeks. It will be voted, it's a popular initiative, which will be voted within 3 weeks. Then we have lobbying activities. We are active in politics for CO2 emission regulation, mandatory due diligence, and so on. And we have a lot of events, of course, at the moment also in the virtual space, not in the physical space, and we have also courses or webinars at the moment, more webinars, of course. But I think the most important activities, or maybe also the long-term activities in sustainability are our research initiatives. We have several sustainability research initiatives in Switzerland, which are financed partially by us, but also by Swiss companies. We have, for example, with EMPA St. Gallen, we have a project which looks at endlessly recyclable fiber through a new spinning process. Then also with EMPA St. Gallen, with another team, we had made a study about the textile waste streams of pre-consumer textile waste. That means the textile waste from production, which could then be recycled or could then be given to a closed loop process. We are actually at the moment working at this project. Then we had we are having a project or finance project, TechCycle 4.0. It's a closing the loop project for clothing, post-consumer clothing with Hochschule Luzern. And then we are of course active in the EU in the Recycling Hubs initiative, where EU wants to make 5 recycling hubs on the whole EU regions, where all partners should stay together to make recycling of clothing easier than at the moment where there is no technological solution. And then we have a blockchain project for traceability in the supply chain, but this is at the moment due to COVID it stopped, but I hope we can retake the action on this really interesting international project also. So what are the opportunities I see at the moment? I think at the moment really the time is now. That's what I hear often for companies. The time is now regarding sustainability. We have here in Switzerland worldwide leading research institutes, and for closing the loop for the circular economy, we have one system implemented already, and that is the separate collection of textile waste, which is implemented in Switzerland just for 10 to 20 years. So it's really well established. We have the collecting and sorting industry here. And industry waste is punished with a fee. So industries really want to make separate collection. I think that it's one good opportunity, but of course it's not the solution to all. And then we have quite strong regulation and the controlling by the authorities. So companies are really attracted to make sustainable businesses. But of course, like in other countries, we also have difficulties. We do not have no complete textile supply chain within Switzerland. We have the customers, we have the producers, and we have the brands, but they are not connected within one supply chain. So we have a lot of traders or people importing textiles, and the customers buy textiles which are imported, and the producers here in Switzerland sell their products on international markets. So they do not have anything in common, which makes projects quite hard to get all at one table. And then, of course, we have the Corona situations. Priorities are at the moment on economical factors, welfare, and factories are closing at the moment. So some projects were stopped due to financial issues, Corona issues. And one big issue, of course, when closing the loop is the lack of technical solutions for closing the loop. The need for big investments and low return at the beginning. That's one of our challenges we face now, but I hope we can go through this. Now our goals, our realistic goals, I have to say, is that I really think that we should now get all our members on board on the sustainability track. I think we are on a good way, but we have to keep engaged. And then I hope that we can keep the engagement of our forerunner members in the sustainability research project, although they have difficulties with Corona at the moment. We want to broaden our networks and engagement with other stakeholders through our initiative Sustainable Textiles Switzerland. So that's also, I'm quite pleased to be able to talk here, because we want really, with this initiative Sustainable Textiles Switzerland 2030, we want to reach SDGs faster than without partnerships. So I think partnerships are really the key of all. And one of my visions is, but maybe it's still far away, is to install a pilot recycling plant for post-consumer waste, but might be just a dream within the next 3 to 5 years, but we will see. Maybe we will reach this goal. So I thank you very much. Maybe you have some questions. I'll be glad to answer them now or at the end of the laser talks. Thank you.
Thank you so much, Nina, for the fascinating talk and peer into the world of Swiss textiles. Unless there are any questions out there, of course, you can always submit them later on through the Q&A chat box at the bottom of your Zoom window. We will move on to our second speaker. Okay, give me one moment. Our next speaker is Yuli Fuentes-Medel. Dr. Yuli Fuentes-Medel is a catalyst of creative ideas and ecosystem builder, and she works at MIT as program manager of fiber technologies. She is also the founder of Value of Science and advisor to venture fund closed loop partners. She created D-Science, a global collective of designers, scientists, and technologists, connecting the world of science and design as one. She graduated with a PhD in biomedical sciences from MIT's medical school and trained at the MIT Sloan School in Technology, Innovation, and Entrepreneurship. Yuli is energetically involved in fostering international innovation ecosystem and careers diversity, currently serving as president of the board of the Chile-Massachusetts Alliance to support international exchange of investment, technological business, talent, and social impact. She is no stranger to international network building and collaboration in innovation, tech, and science. Trained as a biochemist at the University of Concepcion in her native Chile, she is constantly in the search of opportunity to support young talent and technologies that need to make an impact in global markets. I will let you take it away, Yuli.
Okay, can you hear me?
Yes.
Yes, excellent. Meantime, I do the share screen. Yeah, there we go. One anecdote, science art. When I did the science, you guys were the first one who reached out. We want to know more. What are you doing? And we end up with 65 teams in 47 different cities doing fashion and science. So thank you for that. And now we're back here. So thank you for the invitation. The goal that I was asked to give you is a flavor of what's going on in Boston. I was happy to hear what Nina was saying from the other side of the pond. So sustainable fabrics at MIT and Boston at large. So I'm going to speak about MIT, but to do that, I wanted to take you to the map of Massachusetts and kind of bring you home on where we are now working from home, but here we are. Massachusetts is a highly concentrated hub of innovation. And if you see here, most of the innovation activity happens across the Boston area, and we have 100 universities, investment in research and development. So things that happen in Massachusetts are always with the tech heavy impact, and that it is part of our DNA here. One of the particular geographies that where MIT is located is Kendall Square. And if you guys have been in Boston, or the ones that are launching here from Boston, MIT is all this pink area. It's a land of innovation. But then it's around Kendall Square of all these companies and pharma and IT that really creates like once in a planet space to create different types of innovation. So the mission of the Institute is to advance knowledge, educate students in science, technology, and other areas that will take us to the future centuries. And that speaks loud on what's going on in terms of people. MIT has a pride of 89, for example, Nobel Prize winners, and we produce about 375 patents a year. Let's check that number with COVID, but that's the average. And if you think about the students, 30,000 of them have created active companies. So it's in DNA of MIT to not only know knowledge, but also to produce an economy of innovation that is good not only for Massachusetts, but for the world. And if you just compare, as a fun fact, the GDP of all those companies total is 10%, is the 10th largest economy in the world. So MIT is really proud of that. We also know that technology is one piece of the puzzle, and I think that's kind of the philosophy I was trained in MIT to do when I launched Value of Science, that industries have their own challenges, consumers that have their own needs and preparations, and the technological solutions live in a network of all those conversations. And I think particularly for fibers, we have taken an approach, which is the initiatives I'm leading, in thinking, yes, you can have all the objectives of what a fiber is and really fiber-centric, but those fibers have to be in balance with what we're doing with humans and what we're doing with the planet. And then a line down there, the innovation research has to create the supply chain that goes from the tangible to digital, and most likely from manufacturing to the information that is revealed out of that creation of fibers. So I think that in this is, in a nutshell, the philosophy we're taking in how we are creating portfolios of fibers in MIT. Not only that, but MIT has a history. In the 1900s, this is a beautiful picture. I'm really a fan of it. Professor Edward Schwartz created the first textile department, and it was the first time that in the States, before all the manufacturing went to the Carolinas, took a fiber under the microscope. So MIT participated creating the first textile department in the United States when all that was happening in the 900s. And 2016 was a pivoting point for MIT to really rejoin the conversation. Many years have happened, and it was when Professor Joel Fink created a fiber that is called the multi-layer material fiber that gave rise to a whole new idea of how fibers are going to play in augmentation for humans. His process took place, and here you can see as a demo. Doesn't mean we're going to be all wearing LEDs, but it's basically the fiber in itself can have a computer inside the unit. So you could create completely different type of textiles that now have the computational capacity of your computer, and now you're watching this. That allows MIT to be part and create this nonprofit, which is, I encourage you to look at, which is called AFOA, that brings, that is the Manufacturing Institute for United States to kind of rethink what are we going to do with the fibers. You can see here there is a vast number of companies that are members, and AFOA is from MIT headquarters, the engine for the country to kind of rethink what is going to be the fiber of the future, never mind what are we going to be doing for sustainability, which is questions that are still ongoing with these technologies. For MIT, and this is a view from the Domo in MIT and the river and looking at Boston, our fashion style looks most likely like this. We have been doing most of the fashion that goes to aerospace. We can be heavy participants, and we have, for example, Professor Newman, who is designing the biospace suit that is going to take us to Mars. How is that valuable for the apparel space or for the development of textiles? It's an extreme design condition that, imagine if you have to take one piece of clothing for a spaceship. Planet Earth is also our own spaceship. So the thinking and the development of any material in that mindset will serve people in how we are designing clothing back here in Earth. The other fashion style is the Professor Huger, who is a professor who does the biomechatronics, right? So he once, when young, lost his extremities, and he said, well, how can I build my own legs and connect them with my nervous system? Therefore, I'm not longer in disability, rather that I'm in capability and augmentation. So the mindset of MIT research really goes into how can we explore the extension of humankind. We have also Professor Neri Oxman, who has working, and many of you who are here were big fans of her work, where she's been merging architecture and biomaterials. And projects that her work has executed is to take the 3D printing now with materials that challenge the materiality of the elements, the biodegradability of those elements, but in scales that in the future we can see for other manufacturers. And I'm looking forward for Jenny's to tell a story that we will see. Another professor that is also been working with textiles and thinking in the textile as a programmable unit is Professor Skylar Tibbetts, who basically, for example, designed this shoe that is one piece of a textile, but because he's now able to program the textile in an origami fashion, it became a shoe. So challenging really the manufacturing process that today we know for the textile industry, changing completely from what we think it should go into knitting, woven, but building a product on the go. And potentially using even robotics, right? So some of the projects that they've been executing is that how we merge this intersection of technology with robotics and with the textile itself. And for example, here it's a sweater that you can see is changing shape after the fact it's being manufactured because the robots can do so and change color. Tell me how I'm doing on time, because I want to also take the time to think about the big space on Boston.
You're fine in time. Could you just check if something's clicking against your mic? There's a clicking sound that everyone can hear.
Oh, I'm sorry. That's good. Thank you for that. I think it's my jacket. I'm just gonna open it.
Thanks so much.
There? Yeah, now I'm a little bit more naked, but mic fine. Okay, so to summarize what's going on in MIT, we're really working in different buckets: material science research, rethinking the manufacturing technologies, and rethinking the metrics how we are going to build the life cycle assessment for textiles. And in that, really driven by the mitigation of gas emissions globally, and of course, the CO2 problems that everyone is facing. But we're not doing it in a vacuum. We're doing it in a holistic way where everything takes part, and we're creating something that consider all these problems and the interception of the problem as a whole blueprint for the future of the fabric that we want to create. Some of the showcase from Massachusetts back into what's going on. One of the iconic companies that came out of MIT is Ministry of Supply, that they used all the knowledge that's being used in the spacesuit to build a company that now has the capability to kind of create performance, but in the suit, and thinking in the technologies that need to go behind when every single man is using a suit. Could you run a marathon with it? But because now we know the capabilities for a spacesuit, you can bring that to planet Earth. Innovations like nervous system, where they were thinking in the additive manufacturing, how can you bring 3D printing to the form of a dress, or voxel, which is a hardware innovation that you could be really accurate in the 3D printing of a shoe and using just the material that is needed to manufacture a shoe. So no waste in the process. So also reminding you that Boston is the house of Reebok, and they just launched this sneaker that is biocomposable. And I think they can really do that because we are in a network of people that is really thinking differently about what we will do with the future of fabrics. Another company is Jinko, who has been taking synthetic biology to develop organisms. And it's literally like a farm of organisms that will be the raw material for future things that are going to be built in different markets. But this is a beautiful demonstration of how they're thinking about textiles and how they're incorporating bacteria into the process. And some exhibitions they do with interactions between scientists and artists, and in this case, Dr. Nesai, and this beautiful collection that she created with bacterial pigments, and how could you thinking industrializing. And not only that, but for the perfume space, this project that Jinko created was, how can you bring essence from extincting flowers, because now you have the DNA of the flower, and bring it back to 2020, where you can have a perfume of a flower that didn't exist. And that's only being done because you can play with the synthetic biology of the plants. Cotton, we have this company called Gali in our headquarters in Boston. Gali is thinking, how can grow cotton in the lab and build it from the basics of, with the biotechnology knowledge that Massachusetts has, and now bring it to the biotechnology of plants. And silk, we have Professor Aminetto in the Tufts University, who has developed a whole platform of uses and forms of silk for different space, both in apparel and also in the medical space. And some of the patents have created companies like Evolve by Nature, who is a company that is taking silk and bringing it back to the cosmetic space. So to finish, I want to say textiles is an industry that touches every human in the planet. We do have an opportunity to reinvent it. And I'm so excited that you guys invited me to talk here, and looking forward for your questions. And there is my contact info for future, if anybody has a question.
Thank you so much, Yuli. It's always good to hear about what's going on at MIT and its variety of interesting projects. Alex, are there any questions out there we should take now, or should we continue on to Jenny and take some questions at the end?
Yes, we have one question here from Hannah Koch, or Koch. She asks, do you have numbers of how many of these 30,000 companies from MIT and textile companies are in the Boston area?
Okay, so that number is a report written by Professor Ed Roberts. It's a famous report that was written back in, it's now old, 2018. That is not the total number of textile companies. That was an initial set on all the companies that MIT has created. The number of textile companies, of course, is reduced. And right now, with the FOA initiative and with the Fabric Hub initiative, we are revamping our pipeline of textile-based companies.
Thanks so much. And we'll keep feeding you all questions as they come in from the audience. Please feel free to ask any questions you have to any of the speakers in our Q&A function.
Okay, and last but not least, we will move on to Jenny Sabin. Jenny Sabin is the Arthur L. and Isabel B. Weisenberger Professor in Architecture and Associate Dean for Design Initiatives at Cornell College of Architecture, Art, and Planning. There, she established a new advanced research degree in matter design computation. She is also the principal of Jenny Sabin Studio, an experimental architectural design studio based in Ithaca, New York, and director of the Sabin Lab at Cornell. Jenny's work investigates the intersections of architecture and science and applies insights and theories from biology and mathematics to the design of responsive material structures and adaptive architecture. Sabin holds degrees in ceramics and interdisciplinary visual art from the University of Washington and a Master of Architecture from the University of Pennsylvania. She was awarded a Pew Fellowship in the Arts in 2010 and was named a USA Knight Fellow in Architecture. In 2014, she was awarded the prestigious Architectural League Prize. I will hand it over to you, Jenny.
Thank you so much, Julia. It's a pleasure to take part in this fantastic event, Laser Talks. Really amazing talks so far. So I'm going to go ahead and share my screen. And does that look okay on everybody else's end?
Yep, perfect.
Great, fantastic. So I will be talking about biosynthetic architecture and the future of adaptive textiles. So how do we start? How do we start both our research projects and applied projects? We frequently start with very simple parts and components, as well as very simple rules that through feedback and iteration produce much more complex spatial wholes. This interest probes the productive tinkering and misuse of digital fabrication machines with a focus on problem generation over problem solving. We look to alternate industries, importantly textiles, as well as robotics and automation. This is informed by issues of craft and making to produce bio-inspired material systems and software design tools that have the capacity to facilitate embedded expressions in our built environments. Importantly, we also contribute to fundamental science. It has never been about bringing architects and designers into a scientific environment to create pseudoscientists or vice versa, but to come together collaboratively around common questions and problems. And these are some of the recent publications, as well as older publications that we have participated on. We ask, how might buildings behave more like organisms responding to and adapting to their built environments? I believe that in the not so distant future, materials will not just be elements and things in buildings, but they will generate immersive spaces, acting upon and responding to affordances in our built environments. Like the cells in our bodies, sensors and imagers will learn and adapt, making materials not only smart, but also aware, sensate, and beautiful. One of my longtime collaborators, Dr. Peter Lloyd-Jones, introduced to me very early on the extracellular matrix. He is trained as a matrix biologist, and we started a hybrid research and design unit called Lab Studio in 2006 when I was teaching at the University of Pennsylvania. And what this presented to me very early on is a series of very powerful ecological thinking models, stemming from natural systems and specifically matrix biology, and bringing that into design and applied projects as a way of thinking systemically about relationships, and importantly, thinking about how context or environment specifies form, function, and structure. And so we were specifically looking at how the ECM, the extracellular matrix, acts upon and alters DNA as a series of reciprocal feedback loops. So I'm going to focus on just two projects in our short talk with a specific focus on textile tectonics and adaptive environments, building upon that fundamental question that I just posed, but also looking at how we might design and enhance architecture with the bioarchitecture and behavior of our own bodies and local environments. So I'd like to focus on Lumen, which is a project that I won by commission, by a competition as part of the Young Architects program in 2017. The Young Architects program has been in place for about 20 years, and we were very fortunate to be shortlisted and then to win the competition. And as you can see in this slide, to pull off this complex project in a very short amount of time with what I'll call a creative budget. It takes an army of people, students, my senior designers, collaborators, contractors, and beyond. When I embarked upon designing and eventually fabricating Lumen, I was building upon years of work, specifically looking at textile fabrication, and more specifically looking at what's called whole garment, a process innovated by Shima Siki, who I've been collaborating with since 2012. And this collaboration came forth through a commission coming to me from Nike. In 2012, they formed the Flynet Collective, and they were about to launch a new technology, now very familiar with all of us, the Flynet. And they invited 6 designers and architects to respond to the core benefits of the Flynet technology, including lightness, sustainability, form-fitting, performance, and so on. And it was during the production of this pavilion that I started to work with high-tech responsive fibers, building upon years of research across disciplinary boundaries, designing with light and energy, and specifically working with photoluminescent fibers, fibers that absorb UV and then release that back as light, as well as solar active fibers, which change color in the presence of the sun or a UV source. Later, I was fortunate to receive another commission from the Cooper Hewitt Design Museum, where I began to form a bridge between the multiple years of deep investigation into multicellular structures with Peter and in the context of Lab Studio, not simply mimicking or translating what might be a beautiful cellular form into a built space, into a materialized architecture, but to take those relationships, part to whole relationships, looking at how surfaces are formed by cells, how they bifurcate to form larger forms, as a way of thinking systemically in design. At that time, I started working with Arup very closely to really dial in the transmission of tension forces through the complexity of the knit, so that we could bring that back to our own tools and simulation tools to work in a generative fashion. And these are some images from that project. And so when it came to embarking upon Lumen, I felt very confident that we were ready to take this material system to an altogether radically different scale, and to also bring it outside. And this is a view of the large canopy structure in the main courtyard at MoMA PS1 in Long Island City. To date, this is our most ambitious project, our largest project that we've taken on in the context of adaptive textiles. I was very interested in how the project would operate as an environment, that it would be very different depending on when you would visit, either during the day or at night, and that people could really take ownership of the project in terms of thinking about materiality as being something that's co-produced between ourselves and human perception, and the ways that materials are changing and transforming. So we worked with the existing site, both the main courtyard as well as the smaller courtyard. As part of the brief, you have to also design and fabricate seating. And here you can see some of the spool stools, which were formed from recycled spools. We deconstructed the tops and the bottoms of the spools to form a cog, which was then, for the prototypes, robotically woven with photoluminescent microcord and used as both tables and stools that people could move around in the installation. Here you can see some of the photoluminescent fibers activated at night, which was the first time that we were able to actually work with sunlight, to develop simulations, to understand how the materials would change, and also to collaborate with focus lighting to enhance that in the evening hours for events through an integrated lighting system. Here you can see the solar active fibers activated that would change these sort of subtle colors throughout the day, from pinks to blues to yellows, and some details highlighting how we integrated with the existing matrix of courtyard walls, these concrete walls, tensioning into them, stitching into them. Also, as part of the brief, they require some element of water. As you can imagine, during the summer months in New York City, it gets quite hot, especially in these courtyard spaces that have no shade. And so we integrated a misting system. We also integrated some IR infrared sensors that were connected to solenoid valves. So as you would pass by these misting systems, this was the misting corridor, a view from above, it would activate the IR sensors. And so the whole system would sort of breathe and hiss. And it actually worked quite effectively to cool the local microclimate. Here, another shot during the evening. You can see, again, the fibers being activated, a view of the smaller courtyard, both during the day and at night, and a view of one of the 3 tensegrity towers. The project featured 3 42-foot tall tensegrity towers, strategically located at the center points of the canopy structures to lift them up, but also adding a sort of third envelope of adaptation to the project. The entire project was designed to be adaptive, to move, to take wind and flutter, as well as to finally coordinate how the fibers were transforming through both the day and the night. And I think for me, one of the most exciting aspects of the project, again, was to see how people used it, to see how people really kind of claimed it and made it their own. And these towers were engineered to take live loads, such as people climbing on them. Of course, they were not supposed to, but of course they did, especially during the Saturday warm-up events when MoMA PS1 features live DJs, incredible artists invited from around the world to perform. Some of the feedback that I received from visitors included, you know, they would talk about how they felt calm. They told me that they wished Lumen was in the playground of their child's school, or they wished that it was in a hospital space. And so there was something about the biosynthetic nature of the architecture driven by relationships and modes of thinking stemming from the natural world, specifically cellular biology and material science and beyond, that generated moments of transformation, of wonder, of play. And for me, that's, as an architect, something that continues to drive the work as a series of inspirations. The project held up quite well. These events on Saturdays that featured between 5,000 to 7,000 people were incredibly anxiety-provoking for myself. I didn't anticipate this many people coming to the project, but it held up well, and people just really fell in love with Lumen. And this image in the context of the pandemic and the complex time that we're in is sort of difficult to digest. I hope at some point we'll be able to gather like this at MoMA PS1. And so in the last few minutes, I will conclude with a more recent project. Lumen was very popular amongst people that visited the project, but also around the world. She photographed quite well, and we were fortunate to be in the top 5 most Instagram design projects around the world that year, which was a huge surprise. And it has opened up new avenues in my practice for experimental work as well as permanent built work. And this project for Microsoft Research, as part of their Artists in Residence program, is one such project. Ada was a collaborative project with several research teams at Microsoft Research in their Redmond campus in Washington State. And to our knowledge is the first architectural pavilion to integrate AI, artificial intelligence, and to integrate that with textile fabrication processes and design methodologies that inform an interactive experience, for the most part focused on human sentiment and issues of well-being and our relationships with our environments, and ultimately to consider a project that would be human-centered. And so I'm going to play this video just to highlight the project in the last minute or so of my talk. Ada is driven by artificial intelligence. It's a project that smiles back at you. The name comes from Ada Lovelace, one of the first computer programmers, and the linkages between weaving and computation. Knitting is one of the earliest examples of 3D printing, additively layering link by link, row by row material. The project features soft forms that are more feminine versus masculine, and that's a paradigm shift in architecture. The shape of Ada is an ellipsoid. It features a unique exoskeleton composed of a network of fiberglass rods and 3D printed nodes. Every single node is different and has a unique ID attached to it. The interior surface is composed of hundreds of digitally knit cones and cells in a network of webbing. In the center of Ada is a large tensegrity cone composed of a skin of fiber optic cables. Photoluminescent fiber absorbs energy from the lighting and then emits that back as knitted light, as glowing light. But the real magic comes through how people actually engage with it. On the interior soft surface is a whole network of LEDs connected to a network of cameras within the atrium, reading the facial expressions of people in an anonymous way. When Building 99 is very active, the project will be very vibrant and highly transformative. There are moments where it blushes. The hope is that people realize their engagement is actually driving the project, that the project begins to gain its own life in the way that it is interacting with people. And so just briefly to highlight a few of the details, this is a drawing that showcases the material system and how the semi-rigid exoskeleton integrates with the soft surface of the interior, composed of digitally knit whole garment cones and cells. Some details of that, and then also highlighting the software architecture. It was an incredible experience collaborating with teams at Microsoft Research. And here you can see how we worked with the live data feed of anonymous patterns picked up by a network of cameras in the atrium, and how that translated to a 3-scaled lighting system to integrate and activate the materials. We were also looking at the ethical aspects of AI, especially in terms of the terms that we associate with facial pattern recognition as sentiment, and all of this was developed to be parameterized. So every variable could be adjusted in terms of the colors that the light was emitting and so on. Some details of the fiber optics. And I'll just conclude with a few points. An important aim of the project is to expand and inspire human engagement. And while artificial intelligence powers the project through the precise narrowing and statistical averaging of data collected from individual and collective facial patterns and voice tones, the architecture of Ada augments emotion through aesthetic experience, thereby opening the range of possible human emotional engagement. And in turn, the project opens new pathways for fundamental research on the use of AI to correlate connections between human sentiment and local environment. Ada, importantly, will also be used as a platform for researchers to test their data and machine learning algorithms at Microsoft Research. So unlike the pioneering work of Mark Sager, such as his Baby X project that seeks to humanize AI through more, quote, symbiotic relationships between humans and machines, Ada does not appear lifelike. Instead, Ada offers subtle and abstract interactions with humans through space, material, and form to augment and expand our emotional range in a specific context, in this case, an office environment, which in turn affects the probable sentiment being collected as new information. The spaces and environments that we inhabit influence and partially shape who we are and how we are feeling. And through the integration of responsive textile materials and emerging technologies, Ada offers an interface for personalizing architecture to make it more human and reflexive. And so I'll conclude with this last image, and I've shown you 2 projects. We have a lot of projects ongoing in my lab as well as my practice. Here's where you can find us. We've been very fortunate to receive a great deal of support from foundations and institutes over the years. And thanks so much for your attention.
Thank you so much, Jenny.
Yes, thank you, Jenny. I can attest, I visited Lumen in person, and it was both beautiful and refreshing.
So, if I could just ask Nina to turn back on her video as well. We'll take some questions from the audience for these last few minutes. So I'd like to start off with a question to all of you, actually. So you all mentioned in some way or another the importance of cross-sector collaborations and kind of functioning within ecosystems to push forward innovation in textiles. Jenny, you mentioned that you worked with Nike and with Microsoft to develop some of these large-scale projects that I'm sure without private sector partners would have been much more difficult to realize. And Yuli, you mentioned how important it is to have this link to Ginkgo Bioworks and Reebok and similar companies in the Seaport area that then collaborate with MIT. Nina, you also mentioned that it's a priority in what you do at the Swiss Textiles Association. So I wondered if you could just maybe speak to how you create those ecosystems. How do you create those connections for some of the innovators and researchers that might be listening today that are wondering, yeah, but how do I get those connections to the private sector?
I can take a stab for the use of time. So actually, that's kind of how my work when I did my postdoc. How do you really build ecosystem to build this connection? And I can answer in two realms. One is, the truth there is that beyond the technology or the space you're creating, you are building relationships of trust. In the moment that collaboration gets built, literally what the transaction that is happening is trust. And that is what allows creativity. That's what allows researchers to work with companies, companies to work with researchers, and kind of build that pushing the creativity to the level where we create new technologies. And the second thing I would say is that for the practical specificity of textiles, because of my background and kind of I would use the word architecture, but I'm not an architect, but a system design inside MIT is not only thinking in the material in a vacuum, but thinking with the rest of the community of MIT that this material will do a design and integration. It will meet certain metrics in how it's going to perform for sustainability. It will need the interaction with the humans and the consumer. So being able to build a community that has that channel of communication among themselves, and Boston is famous for that, is critical to kind of push the barriers for what do we want to see for textiles. So I would stop there.
Any additions from the others?
Yeah, maybe I could just jump in here. We made really good experience just as we are more the company side of the of the project. We made really good experience with just making such events where we have researchers on stage talking about their visions or talking about their projects, and we have companies in the audience. And then we have outside of the events, we have these networking corners where we have tables where the research teams present themselves and companies go there and just talk to them on a face-to-face interaction. And that, I think that a lot of projects started there because they really had to talk to each other, and then they could just exchange contact details, and then they called afterwards and the project started. So it's really, they just need to know about each other, what they are doing. Then they see, okay, we have some connection, we have some touch points, and that where the project starts.
Yeah, I'll add just a few points to echo both comments. I mean, Yuli, I completely agree. The transaction is trust. It's always about building trust, and each successful project and collaboration demonstrates to the next potential collaborator, the success and the trust that has been developed. So, for me, it's about those relationships and friendships, and also pushing oneself outside of your sort of comfortable territory, which I think we're all in good company here in this laser talk. into other disciplinary spaces, and to come to that space, you know, with your area of expertise, but to be open and, you know, open to conversation. And I'll just mention that one of the most important things that my longtime collaborator Peter and I did early on was to spend a year just figuring out how to talk to each other, you know, and how to communicate and to understand our different structures for how we lead a day, how we get funding, how we lead projects. And that was really, really important, because that was about trust building.
I would like to add something there, which Jenny, 2 points. One is in my private practice, when I'm with the hat of an investor for the fashion industry. Traditionally, the fashion industry is not a collaborative entity. You normally are competing for characteristics in the company that wants to keep the secrets, because that's what makes you a really cool brand, right? So transitioning the fashion industry as a market space to these collaborative practices is essential also for the textiles to see a place and to kind of make a new face in planet Earth. To me, it's not surprise, and I know Asta pretty well in Microsoft, that Jenny is doing the AI project with Microsoft, because a technological company knows that with collaboration, they can push their technology. But for the textiles, I think we still need to kind of build that trust and see the economical benefits of why they need to collaborate. And I think that's a challenge if we put it also out there.